What have we done so far? We designed an example application, and then among all the classes, we identified a class that could act as a singleton. Finally, discussed the various implementation approaches of singletons, each with its own benefits and drawbacks. Singletons are very common. Also, it's very easy to identify such classes and apply the pattern. Also, they are very easily accessible just with one public get method. However, its easy accessibility from anywhere in the code becomes a cause of concern for many, especially the test. In fact, singleton is treated as anti-pattern, especially in test community due to these very issues. So let's look at the main drawbacks of using a singleton. Singleton makes a class almost impossible to test. To see that, consider this sample code. This is a game controller method, showCard invoked. This method is called when user clicks on one of the cards in the game UI so that he can see the number on the card. If you recall, there are a few conditions before the controller can decide to show the card to the user. Firstly, the card should belong to the human player, not the opponent. Then we check if the place where he clicked actually holds a card and is not an empty placeholder. And if the card does exist in the clicked place, then we check if it is face down. If we clicked on a card whose face is already up, then there is nothing to do. It's only after these conditions succeed, controller will take the next step to show the card, which is to call the mapper to reveal the card and then call the model to update the status of this card from face down to face up. As you know, we have made app model a singleton class. So the controller is going to access its instance using getInstance method. So here I made a call to getInstance method and assigned it to a local variable app model. And I use it wherever I need to call method on the model object. Now let's say I want to unit test this method to check if game controller class functions as expected. That is, I want to test that it correctly performs all those checks, and only if those checks succeed, it goes ahead with the next steps, which is to call the methods in mapper and model class. Let me also show that game controller calls mapper, which in turn calls viewer to update the display. Let's say in my unit test, I'd like to stub out a few of the classes. These are view. That's because view is all about UI display, and I don't want these UIs to appear in my unit test. Other class is singleton class itself, that is the app model class. That's because app model class is a resource intensive class that accesses the real SQL database to retrieve the images, etc. In order to be able to mock these two classes, we need to examine how our main method instantiates all the classes. So let's look at the main method first. I instantiate the view and controller classes. I also create the mapper object to which I pass the view and controller objects. Then I use set mapper methods in both view and controller classes to set the mapper object. There are similar calls for the character UI, that is creation of view, controller and the mapper objects. Then I instantiate the main application class and call start to start the application. I mentioned that we wanted to mock view and model classes. But if you look at game view, it does not implement any kind of view interface, something like iGameView. Only if it implements such an interface, we could mock our view class. So let's say we decided to have an interface iGameView, and our game view implements such an interface. So now it is possible to create a mock for this class. Then how does our test code look like? We create a mock game view object and then we instantiate a real game controller class. We also instantiate a real mapper class. To this mapper, we pass the mock view object and the real controller object. Then we set the mapper object in both view and controller. Here is a small quiz for you. This test code is not going to work. Can you identify the reason for the same? Pause the video for a minute or so and resume once you have identified the reason why this test code will not work. This is all fine, but what about the app model class? In this entire main method, there is no mention of app model. You do not see app model being passed to any of these constructors. That's because the app model instance is obtained by a call to getInstance method, which you will find throughout the codebase, wherever the model is used. So effectively, we have hidden our app model class from the tester who wants to unit test any of these classes. This test code is not going to work because internally it still expects the real app model object, which needs the real database to work with. This makes it almost impossible to test our controller class and nearly the whole application. Singleton also encourages tight coupling. And let's see how. In our example, our Singleton app model object is used by at least 4 classes: game view, game controller, character view, character controller. If game controller changes the state of the model, that means some changes have occurred in the value of model's member variables. And that would affect the game view if it is accessing that value. Likewise, any of these classes can change the state of the model object, and changing the model state will affect the rest. This makes all these classes dependent on each other, making almost the entire application tightly coupled. Here we have just 4 classes that are dependent on the model object. Imagine a real application with 100 classes where Singleton is widely used. In such a tightly coupled application, debugging issues becomes a nightmare because we don't know which object modified the Singleton state. In summary, it would not be wrong to say Singleton is a class with a global state, accessible to anybody and modifiable by anybody. So what do we do here? Should we stop using singletons completely? The answer is not in all the cases. In applications that use logging, loggers are almost always used as a singleton, and they are used everywhere. Some experts feel that using loggers as singletons is acceptable. That's because they don't affect the execution flow of an application. Flow of information is always from application to the logger. There's nothing that goes from logger back to the application, which would affect the state of the application. In other words, whether or not loggers are present, applications behave the same. In such cases where the presence or absence of a singleton does not affect the execution flow, it is okay to use the pattern. Then what about other cases where the information needs to flow in both the directions? If we cannot use singleton in such cases, what should we do? Before we understand the other alternatives to singleton, let us go back to our formal definition of singleton. If you recall, singleton ensures 2 things. It ensures only one instance. Secondly, It ensures global access. Now, the main criticism that Singleton pattern faces is not that the pattern ensures a single instance. The criticism is with the second part, that the pattern allows global accessibility. Anybody and everybody can access it and modify or access its state. That's what is the root cause of all the issues. In most of the cases, an object is needed at most by a few other objects. But since Singleton is available, people use it as a convenience to fulfill their tasks easily, even if the architecture does not allow it. So, how do we ensure that only a single instance is created, but not provide global access to it and accessible only to those objects that really need it? By using factory and dependency injection. Factory will be responsible for creating all the objects of an application. It will then use dependency injection, which will ensure that we pass objects only to those that need them. No global classes. For example, it creates object 1, and if object 2 needs object 1, it passes object 1 to object 2's constructor. Similarly, it passes object 1 and object 2 to object 3's constructor. In summary, every class makes its dependencies clear by explicitly taking them as parameters, mostly in their constructors. Let's quickly see what this all means in the context of our example. Existing code in the main method using Singleton pattern looks like this. We have already seen this code earlier. We are instantiating view, controller, and mapper classes. But there is no explicit instantiation of appModel class. Since we want to ensure no one creates more than one instance of appModel, we had designed it as a singleton. Every other class used the getInstance method to obtain the reference to that single instance. Can you take a pause here and try converting the code in main app to use factory and dependency injection? Recall what we learned about factory and dependency injection and see whatever is possible from your side. Resume the video once you're done with your changes. Now, with dependency injection in place, we would have a factory class called appFactory, whose sole responsibility is to instantiate the classes. Also, we will not hide appModel class anymore. AppModel will be a normal class like view and controller with no private constructor. So we explicitly instantiate the appModel class here and pass its instance to view and controller's constructors. That way, we are declaring to the world that view and controller do need appModel object. And then we no longer make getInstance call to get the instance, as we would have already stored the model object as the member variable. They will simply refer to the member variable whenever they need to call methods on the model object. These lines to set the mapper, etc. remain as they were. Because the factory is creating all the objects, it can also instantiate the main app class and return it to the caller. Caller in our case is the main method. Now all that the main method does is instantiate the factory class, call its create method to create the complete object graph. Since the factory returns an instance of main app class, main method can simply say start on the returned main app object to start the application. As you can see, we do not have to enforce single instantiation of model class. It was automatically ensured by factory. Factory created just that instance and passed it to those that needed the model object. Of course, for this approach to work, object creation must happen in the factory class, no other class. Now, assuming that model and view classes both implement their respective interfaces, mocking them becomes easy. This makes it possible to unit test the whole application. We have also reduced the coupling here. That's because the factory passes model object only to those that need them. No other class can use the model object as it does not have model object's reference. If you do get into a situation where many classes, not a few, need to use a single instance of a class, then recall our logger example. We need to see the information flow. Is it one directional from those classes to that single instance? Then considering singleton instead of dependency injection may be fine. But assume the information flow is in both the directions, that is, from other classes to the instance and back from the instance to these classes. Then it might be necessary to think really hard on whether all those classes need access to that instance or it is just a few. This might involve a relook at the design, and if they all are still needed, it would still be a better idea to pass that instance to those classes using dependency injection than to resort to the singleton approach. That's because by using singleton, we simply hide the fact that all those classes need that instance and get into all those testability issues that we discussed earlier. Of course, in all the situations, we are talking only about a class that also stores the state and changes with messages passed to it. If there is no state, then we do not have to worry about it. In such cases, we would just be fine even with a static class.